this is the Key for Academic Math Quiz 1 review. So here is my graph. Find the value of f of 2. So this is saying x is 2 because f of x, the 2 is in the x spot. So I'm going to go to my x-axis where x is 2 and look for my graph or my function. That's way up here. That value is 5. F of x equals negative 2. So now they're basically telling me the y is negative 2 at what x value. So I'm going to find where my y is negative 2, which is right here. The x value that lines up would be negative 4. What's the domain? So domain x values, and we always want to go from left to right. So from the left, I have an arrow that represents negative infinity. So I'm going to go from negative infinity all the way to the right side, which gives me 2. Remember to read your x-axis, and I'm going to bracket that because that's a solid point, so I want to include it. What's the range? The range is y values. So you need to go from smallest, so the bottom, negative infinity, all the way to the top of the graph. So if I read from the bottom, there's an arrow there, so that would be negative infinity. The top of my graph on the y would be 5, and again, solid point, so include it. When you write a function rule, this one has 3 pieces, so my piecewise function is going to have 3 equations. The first equation does not hit my y-axis but is linear, so I want to use point slope. And what we do, since there is a y equals or an f of x equals for that whole thing, is I'm going to get this in y equals. So I move the 1 over, and we call this modified point slope. So modified point slope is something really important for you to study. Y equals m, x minus x1 plus y1. So this is modified point slope, and that comes from point slope, which you should also know. We spent a lot of time on it. So either way, you're going to need to find m. So if I count from one point to the other, it's rising 1, running 1. So my m for this one is 1. And then I can use any point. I'm going to use this one just because it's really large. So we have negative 1, 1. So it says opposite of x1, so x plus 1, and then plus y1, which is 1. So when I plug it in here, I'm not going to write the y equals because that's up here. So I'm just going to have x plus 1 plus 1. And if you have a 1 out there, that's fine. Now we need to say the piece for this. So this goes from negative infinity all the way to negative 1. And then I want to bracket that. You could also write this as x is less than or equal to negative 1 because that's the cutoff for that piece. Let's look at the next piece. So this next piece is a horizontal line. Remember hoi for horizontal line. So if it's a horizontal line, it has 0 slope, and it's going to be a y equals a number. Well, y is going to have to equal 1 here. So this equation is y equals 1. I'm not going to put the y equals, so you're just going to see 1 here because the y equals is there out in front. This piece goes from that negative 1 to 1. So I want to say negative 1 up to 1. I did not include negative 1 here since I included it here. It can be in either, it just can't be in both. You could also write this as negative 1 all the way up to positive 1. Third piece is another linear. So I'm going to use modified point slope again. Just make sure you can see where I'm writing. So my slope here is up 1, 2, 3, 4. So rise 4, run 1. So m is 4. My point here is 1, 1. So that's my x1, y1. So when I plug it in, y equals m is 4. Opposite of x1, so x minus 1 plus y1, which would be 1. So 4. X minus 1 plus 1. And you could write this in a lot of different forms as long as when I get it out, it's going to be the same thing. So you could went down 4 over 1 and found the y-intercept would be negative 3 and have this as y equals 4x minus 3. That would be okay too. All right, so this one goes from 1 to 2. So I can't include 1 since it's there, but I do want to include 2 since it's solid. Make sure when you write your domain, you're using your x values. You could write this as 1 less than or equal to x less than or equal to 2. It's not both of these. It's either interval notation or set notation. Set notation, interval notation, sorry. Okay, all right, sorry guys. So the dog was getting a little crazy. So here we want to graph this. There he is again. So the first one is essentially saying y equals x minus 1. So if we think y equals mx plus b, my m is 1 and my b is negative 1. So I'm going to go down 1, up 1 over 1, down 1, up 1 over 1. And then I want to look at my domain. So this domain says I want to be greater than 0. So I'm going to include that point and then all the way to 3. 1, 2, 3. So I just want to have an open circle here because it's not or equal to. So this is why we do our graphs in pencil. And it's just going to be this piece. So piecewise means I'm going to have several different pieces. So my first piece goes include 0 up into 3. This next one is in that modified point slope form again. So y equals m, x opposite of x1 plus y1. So here I see y equals negative 2, x minus 3 plus 2. So my m is negative 2 and my point x1, y1, opposite of negative 3 would be 3 and then y1. So I'm going to start at 3, 2, which means I'm actually going to start where I just ended. And then I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. And this one I want to go from 3. So now this is going to be a solid circle since they overlap here. And then I want to go 4, 5. At 5 is an open circle. So we're going to do an open circle and that piece goes from there to there. Okay, last piece is just g of x or y equals negative 2. So there's that HOI again. So horizontal line through y equals negative 2. So negative 2 is here. It's this line, and I want to include 5. So it actually picks up where this one left off. That's now solid. And I want to go all the way to 8. 6, 7, 8. London, can you please go do that in a different room? It's really loud, baby. Okay, so there's my graph. What's the domain? So domain is x values. I can use my graph and say it's 0 to 8, 0 to 8, or I can just look up here, 0 to 8. Oops, I just realized this does not include 8. So at 8, I want to make sure this circle is open, and when I write my domain, I want to make sure I write it with a parentheses here. Okay, range is your y value. So we want to go from the bottom. It does include negative 2 all the way up to 1, 2, positive 2. And that's a solid point. What's the value of g of 1? So x equals 1. I can look at my graph, would be 0. And a great way to check my graph is to actually use the function 2. So remember 1 is between 0 and 3. So I could plug it in here. 1 minus 1 is 0. So my graph looks right, at least at that point, and the answer is 0. Same thing with g of 6. So I'm looking at x is 6. 1, 2, 3, 4, 5, 6 on my x would give me negative 2. If I plug it into my function, 6 is between 5 and 8, and it says my function should be negative 2. All right, let's go to the next page. Sorry, y'all. Okay, so this is an absolute value. Remember, standard form is y equals a absolute value x minus h plus k. So a is my slope, and then hk, opposite of this, nk, is what's called my vertex. So here I'm going to have y equals. All right, so I need to find my m, and we're going to use this side. It's definitely down. Remember, when the a is negative, it's opening down. This is definitely down. So I want to find 2 good points. So there to there is down 1, 2, 3, and then over 1, 2, 3, 4, 5. So this slope is going to be negative 3/5, absolute value. So my vertex here is negative 2, 3. So opposite of h would be positive 2, and then k would be 3. When you write a piecewise has two pieces for absolute value. Remember, absolute value is the distance it is from 0. So it could be going to the right or going to the left. So that's why we see this V graph here. So the left side of my graph actually is going up from left to right. So it's going to have that positive 3/5, and it's still going to go through that point, that same vertex. And we're not going to write it as an absolute value because that would be making another V. So we're just going to write it in modified point slope. So y equals mx minus x1 plus y1. So I'm just going to use the point -2, 3. You can use any point on that line. And this happens from negative infinity to this point is where it changes. So that's -2, and I want to include that. You could also write that as x is less than or equal to -2. All right, the next part is where the slope is negative, but I have that same point, 2, 3. So the only thing that changes is it's the opposite direction or the opposite slope. And now this piece goes from -2. I can't include it because I did here, so I don't want to include it twice, to infinity, or I could say x is greater than -2. That's the L for the left, so I don't want you getting confused. All right, f of -2. So I'm going to go x is -2. That's 3. That's my vertex. X equals 3. X is 3 is an x-intercept, so that's 0. Now we're going to go backwards. Find x if f of x is 3. So I'm going to go to where y is 3, which is right here. And again, that's my vertex. X is -2. When y is 0, so here's where y is 0 at the origin, it actually hits my graph in 2 spots. So it hits at x is -7, and it hits at x is 1, 2, 3. So it has 2 spots there. Given the slope and point of the line, we're going to write it in point slope. Y minus y1 equals mx minus x1. And modified point slope, which we've done a bunch of times already. So m is -2/3. This is my x1. This is my y1. So point slope would be y minus the y1 equals m x minus x1. So x opposite of x1. Modified point slope, y equals m x opposite of x1, and then plus my y1. Given 2 points, now we're going to do the same thing. So in order to write modified point slope, we know we need our m value. So remember, m is y2 minus y1 over x2 minus x1. So x1, y1, x2, y2, -4 minus 6, -10. 5 minus a -9 or opposite -9. 5 plus 9 is 14. 2 goes into both of these, so I should write this as -5/7. So my m is -5/7. You can use either point. I'm just going to use the first one. So opposite of the x1 would be +9, and then add the y1. All right, last couple. So g of 2. I'm going to go to the function that says g, find x equals 2. Not that point because it's open, so I'm going to use that point. That will be 3. F of -1. So -1 would be less than -3. So I'm going to use -x minus 4. -1 minus 4 would be 1 minus 4. So that would give me -3. F of 2, x equals 2 in this function that says f. X equals 4, would be here between 3 and 10. So x squared minus 7. 4 squared minus 7 would be 16 minus 7. So that's 9. All right, here, this is a challenge for you guys. So don't stress about this, but this is 4 times g of 3. So g of 3 I'm going to go to the G one of 3 would be right here at 3. So that answer is 3 minus 3. F of 10, well, 10 would go in here. So F of 10 is x squared minus 7, 10 squared minus 7, 100 minus 7, so 93. So I'm going to do 3 times 93. So we have 4 times 3 minus 3 times 93, and I am okay if you guys use a calculator for this, but you should get negative 267. Again, this one is a challenge for you. Hope that helps.